So nobody even knows. They're just saying, oh, I want a 272 or I want this 264. They actually don't know what that means. Like that's like a pie in the sky number that it's an advertised number and you don't know really what you're purchasing. You just say, I need that. And I think that camshaft knowledge is really missing in our whole industry.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by David from Head Games Motorworks. Head Games best known for building and developing some of the fastest import cylinder heads anywhere in the world. And head porting is one of those areas where I think there's more confusion and misinformation than a lot of areas of the automotive industry. And from my own perspective, I kind of see this as an area where there is a bit of a crossover between science and art. And it's, as we find out, talking to David, not one of those areas where bigger is always better. Specifically, David has got some very non-conventional views on what works well. But David's views are also backed up by a host of records on the drag strip and in other areas. So safe to say, he's got the runs on the board to really back up what he's saying. Now, I do also want to apologise here to David because we went so deep into this interview so quickly that I didn't actually really get a chance to come back and talk about how he developed Head Games Motorworks specifically. There's a huge amount of information in this interview about what he does, but I didn't really talk specifically about his business. As usual, you can find out more about his business and some links that you can follow to see his business in the show notes, so check that out there. Now, before we get into our interview with David, for those who are fresh to the HPA Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, tune EFI, build wiring harnesses. We also cover topics on race car setup and development, race driver education, data analysis, and fabrication. If you are interested in seeing our full list of courses, you can do that at hpacademy.com/courses. And as a podcast listener, you can use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. All of our courses are delivered via online video modules, meaning you can take them from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So absolutely zero risk giving them a test drive. Again, we'll put a link in the description to our courses and that coupon code. Enough of that introduction, let's get into our chat now. All right, David, thanks for joining us today. Welcome to the podcast. And as we always do, let's get started with a bit of your background. How did you get interested in cars in the first place?
Cars have been in me since I was a child, and I feel like I was just born with this disease of falling in love with horsepower in cars. When I was a child, I brought my parents to car lots, and just because I wanted to look at cars, and my car seat was a couple of phone books on the car seat so I could see above the dashboard watching all the cars driving by. And it just never changed. I went from 3 wheels to a bicycles, and I was riding bicycles and building bicycles. And then I got into cars, and I was about 10 years old. There was a guy in the neighborhood who had a 70 Camaro and had side pipes on it and Kragers, and I had to get a ride in it. And the car probably went 13s, but it scared the crap out of me. And I was hooked. Like, I needed horsepower in my life at that point. So I actually was a paper boy. And for 2 years, I saved my money and I bought a 70 Torino. So I'm in 6th grade, 12 years old, and I have a 1970 Ford Torino that had a 302 in it, C4 trans, and I did some souping up with it, but I also couldn't stay away from not driving it. And I lived
Hold on. We're 12 at this stage. Now, unless the laws are very different in the US compared to here, please tell me you're not able to legally drive on the road at 12.
No, I'm not. No, definitely not.
Okay. Just clearing that up.
No, it's 17 years old to drive in New Jersey where I live. And I'm 12 years old driving around my condominium complex, just having a good time with it. And one day I got in trouble. So because my parents worked during the day, they didn't know what I was doing during school time, during after school. So, I'd be driving this thing around, and one day I drove it around, I guess, too long, and I go and park in the parking spot, and I look out of the car, and there's 2 cop cars sitting there waiting for me to talk to me. I didn't get in trouble. They couldn't believe that I was in the car, but that car had to get sold because I couldn't stay away from it. And then, we went to have like a project car, and I was looking at IROCs at this point. So I was like, I think 15, around 15 years old. And I really wanted an IROC. And we saw a Buick Grand National sitting in the corner of a parking lot, a dealership. And he takes me for a ride in it. And it was the first time I felt boost. Again, it was like I was hooked. Like I needed to have this. This is like the next step in my life. I need to have boost in my life. So we bought an 87 GN or a T-Type. I actually still have the car. It's got 42,000 miles on it. And my dad would take me to the track. He would take me to Englishtown. He would do all the tech in, and then I would drive it. So I raced in the Grand National versus Mustang shootouts at Englishtown a couple times. And I was street racing by the time I was 16. The car was going like 1230s by that point, and we would go to Northeast Philadelphia, like all the guys in my neighborhood, because I'm in the car. So like all the guys that are 18 and above are all hanging out, and we're going street racing. And my dad went there with me until we again got caught. And my dad said he'll never go down there again. We didn't have to sell the car, but at least like I got to go street racing, and I met a lot of people. That was really kind of the stepping stone, or the building blocks for who I am, because I just love horsepower and I couldn't get enough of it ever. Like there was never a time from those 6 years, and then I'm in high school. The car's going like 1130s or so. The second fastest guy in Philly, and believe it or not, I actually failed auto shop.
It's quite laughable given your career.
Well, I mean, the guy looked like Gilligan from Gilligan's Island. I don't know if you ever seen that show. Like he looked like Gilligan, or I'm sorry, the skipper. I'm like, so I got my skipper's cap, and I always told him I was going to bring home his daughter, and he'd kick me out all the time. I was a little bit of a behavior issue. So anyway, I after high school, I got in a little bit of trouble, and again, like I got arrested a couple times. Nothing crazy, but I got arrested a couple times, and I really just needed to clean my act up. So I moved to Texas, and I went to School of Automotive Machinists. And Judson and Linda there kind of took me under their wing, and they gave me a job. I was director of admissions. Through that, because we were building motors, we were touring the NMCA. I don't know if you're familiar with the NMCA tour, but
No.
it's the National Muscle Car Racers Association.
Okay.
So
let's just talk about School of Automotive Machinists. So this is where you'll learn how to machine all the machining operations that go into building an engine. That's correct? My take on that's
correct.
Right? Yeah, okay. I just wanted to clear that up for those who haven't heard of that school.
Yeah, so I took each course is 9 months. I took the block course first, and then I stayed there the full time, and then I took the cylinder head course. And while I was there, we built a race car for this National Muscle Car Racers Association, and we actually set the record first time we went out, and we won the race, and everybody couldn't believe it because it's a tech school. Like tech schools are supposed to be kind of like a bunch of dumb kids, and then we're out here just whooping everybody's ass. And, Billy Glidden was there. I don't know if you're familiar with who Billy Glidden is, but there was a lot of big names that were engine builders for this, and we were whooping their butt, and they didn't like it. But this is where I met Pat Musey. So when I was working for the school, because I went to all the races, Pat was racing in Pro Street, and Musey at the time, it was a pretty big name. You could go buy his toys at the stores, and I got to talk to him because he's from Jersey, I'm from Jersey, and he just kept asking me to come to work for him. And he bugged me enough until I had left the school, and I went for an interview. And his interview was, I walked in there, and he said, "You ever gas poured a piston before?" Now I'm dressed nice. I'm thinking, no, I've never gas poured a piston because that's something that we just didn't have to do. We were doing NA stuff at the school. So he hands me a piston, and he takes one of his own, puts it into Bridgeport, gas ports it real quick, and then says, "You got to do that 8 times. We got to make FedEx." So that was my interview. I had to gas port these pistons, get it done, and get it on in a box so you could ship it. So that's how I started at Musey's. I worked at Musey's for 3 or 4 years.
I'm guessing at the point you started there, given what you'd learned at School of Automotive Machinists, you're fairly well versed at this point with machining and general engine building, obviously in a performance orientated field as well.
I would say no, because like I could machine stuff, but I wasn't as versed in the porting stuff. So when I worked for the school, I was always being called to like give tours for the school. And I found the head porting thing because I could go in the porting room and nobody would hear me. And nobody would know where I am, like
hide away in
I could
there.
just hide away in there, and I'm an artist by nature, so I enjoyed going in there and just carving something out, and that's where I found my niche. That's where I decided I wanted to do. I didn't really want to be a block monkey. I didn't want to build motors, although I could do it. I just felt like I couldn't do it very well. So, but I could port a head very well, and I could machine a head very well. At least I thought I could. And then when I went to work for Musi, I learned very quickly that I couldn't port a head very well, and they all made fun of me. and but they cultivated me. They really taught me well. One of the guys there, Charlie Culp, he used to work for like he worked with Smokey Yunick, and he had stuff in NASCAR. He was married to Harvey Crane's daughter. He just he fell in hard times. We used to call him the wino, but he taught me how to do short turns. And there was another guy there, Tommy Gonzalez. He taught me like so much. At the time, things weren't really CNC'd. Everything was hand ported. We're talking 1997. So almost everything is hand ported. I mean, if you ever seen like a big block Chevy head, that's pretty much all we did. And the ports were something you can maybe put two fingers in, and by the time you're finished, you can put almost your whole hand in it. There was a lot of room to learn how to grind, I guess you could say. I learned how to carve it. Between those guys, I think that's where I really learned to hone my craft. When I went to school, I learned theory because I didn't have anything else to do besides machine stuff, put it on the flow bench, take it off, try something else, put it on the flow bench. That's what I did almost every day for 2 years. And we got to stay there at night, and we pretty much didn't leave. If you're one of those guys that was just in love, they never kicked you out.
Yeah, nice. So you got the run of the place pretty much. You got to play with the toys.
Yeah, so when I worked at Musy's, it was kind of the same thing where he just kind of let you, he's not a cylinder head guy, and we just were able to kind of do what we wanted to do. Now, when I started there, I had to do the way Tommy wanted me to port the head. And then when Tommy got fired, then I got to do them my way. And my way was a little bit smaller and a little bit different. I remember I did a head for this guy. His last name was Hall, and the motor picked up like 70 horsepower. And Pat came back there, and he was like, dude, you're a bad dude. Like overall, everything that they already had, this was a package that they already sold, and shook my hand, gave me a raise. I mean, it was a great feeling. So
that was 70 horsepower just from the work you'd done on the head porting, all other things essentially being equal. Is that what you're saying?
Yeah.
Okay.
Shrunk the intake port, and you couldn't make a nitrous port big enough.
All right, there's a bunch of things that you just sort of talked about here, and I probably should have pre-qualified this with head porting is certainly an area that I do not profess to be an expert in. Obviously, I've dealt with more than my fair share of ported heads. I've seen good and I've seen bad, and I do have a broad kind of understanding of what we're trying to achieve, but it's definitely not something that I would take on myself. And I kind of see it as one of those areas where there's sort of this synergy of art and science, if you like, and trying to get that combination just right is where the real talented head porters manage to pull away from the rest. Now, in terms of quantifying your results, because this is sort of a big element of it, I'm primarily an engine tuner and by necessity an engine builder, and I've got a great tool to quantify the results of everything I do, which is the dyno. And the dyno kind of tells you if you're going in the right direction. And I mean, ultimately, when we get down to it, once you've ported a head, yes, it goes on a dyno, an engine dyno or a chassis dyno, so you get to see the results in that way. But while you're actually developing a head, that's going to be quite a time-consuming and expensive process if you're sort of fettling the port a little bit. All right, let's put it on the dyno and see what the results are. You've obviously got to build the entire engine up as an effort of getting it onto the dyno, see the results, go a little bit further. You got to strip the whole thing down. So for you as a head porter, is the flow bench the dyno of choice? Essentially, that's telling you everything you need to know about what you're doing?
No, I think it lies to you sometimes.
Okay.
It will tell you something. To give you an example, I know we're kind of skipping around here, but when I got involved in imports, I did 2JZs for our Islanian, and I made the port really big because it flowed better. And then we put it on the car, and the car slowed down. And the same thing happened at Muses. Like, if I made the port too big, and that's really the only thing I did differently than Tommy. Like, Tommy said it flows better than mine, but it doesn't run better than mine.
So does this come down to, as I understand it, we've got airflow, but the other element that's just as important, perhaps maybe more important, is air velocity. And on face value, you might think that a bigger port, well, clearly it's going to be able to flow more air. And it sounds like from what you're saying, maybe that's true, but at the sacrifice of air velocity.
Yeah. I mean, it's a big vacuum, right? So like it just has a vacuum on it and has different size holes. That's how a flow bench works. So if you can make the port big enough, it's going to flow more. But when you go to put it on the car, it's a totally different scenario because you have camshaft, you have air, you have all these things that it becomes a combination. I think that the flow bench is a really good tool for the one guy who's using it. And if he wants to quantify some of the head porting that you can do, like you can kind of learn where you're going, but you can't judge everything off of that. And some people do. Some people go and they live and die by these flow numbers. And in my personal opinion, or my experience, it's never worked out that way.
I think in general, the automotive aftermarket is a very numbers driven industry. We've got horsepower numbers off the dyno, so we like to compare numbers. And again, on face value, if I was to compare one cylinder head with a port that, let's say it flowed, 300 CFM at whatever lift, and then a ported head that flowed 350 CFM, well, on face value, the head that flows more, surely that's going to be a benefit. And as you've just discussed, perhaps, but maybe not. That gets into the next question. If there's a little bit more to it in terms of knowing what the results are going to be, where it actually counts on the dyno, out on the racetrack, out on the road, does this purely just come down to hours porting heads, seeing the results and understanding? Do you start building up trends and you can sort of look at a port and go, I kind of know what this is already going to need before I've even got started?
Absolutely. That's exactly what happens, actually, because there's really no other way to quantify it, in my opinion, than how it actually runs. So it's part of the reason why we don't share flow numbers. And people get a little weird about Head Games doesn't share flow numbers. And I don't share flow numbers because even me sharing like stock flow numbers, or if I look on the internet for stock flow numbers, they don't always match my flow bench. And you have to know how to decipher what you're actually reading there. So if you don't know how to read most people are just going to look at the biggest number on that sheet, and they say, "Oh, that head's better than this one." But in reality, that's not true. Especially in the sport compact world, people are looking at, like, usually it's a 500 lift number, and you can't buy a 500 lift cam. You can't find, there's nothing that's half inch.
Yeah, it's a lot of lift for a sport compact cylinder head.
It's a whole lot of lift, and nobody sells it, but everybody's looking at that number.
So the other thing from what I've sort of read or understood in the past is, if you're just looking at that peak number, it's such a small and irrelevant area of the cylinder head's operation, whereas the valve, even though it's getting to half an inch lift, it's only passing through there momentarily. But if you look at the lift at lower valve lifts, it's passing through there as it opens and as it closes, so it's actually spending more time around that. Is that an element that comes into play here of the lower lift flow is actually more important than peak?
And you said you don't know anything about cylinder heads.
But maybe a little bit. I've managed to absorb a lot of information over 20 plus years in the industry. You can't help but pick up a few bits here and there.
Yeah, absolutely. So it's going to go through the range twice. And for me professionally, I just never look for a peak number. I'm never there. I'm always going through the range. So I will size everything. So from the crack of the valve, and sometimes we have to kill that number. I get, that's a whole nother, I don't even want to get into that theory, but sometimes we need to kill the 100 number. But for the most part, we're trying to make it so it flows really good to like 350 lift, because that's where most cams are going to lie. And then, we might get into that 400 range, but we're really not going much more than that. And you could probably switch that over to millimeters. I'm not real versed in the millimeter side of that.
I think an interesting element of dealing with engine building that I've found coming from New Zealand, where we obviously use the metric system, you kind of have to be able to work in both metric and imperial, but really in the world of camshaft grinds and cam specifications, the imperial system for some reason still dominates. So have at it. It is kind of what it is, for better or worse.
Valves, I can talk millimeters. When it goes to the camshafts, it's hard for me to speak intelligently, at least, and fluently about a camshaft in millimeters, besides like a peak lift, but we're not talking about peak lift.
Just one more element with the flow bench. Obviously, we've talked about the fact that it's going to produce a flow number, and that's going to be correlated to a given valve lift. We've sort of talked about the element of air velocity through the port as well. Is there a way of getting data on air velocity, or is that not something you can really directly, easily sort of track?
It's actually really easy. We have a probe. There's different shape probes that we can go in there and figure out where the air is. Sometimes, like, if you move a wall, it will move the air, and you want to see where the air moved to. And then sometimes it moves into an area you don't really want it to. So that's where the flow bench really helps to know, as I said, if the guy knows how to use it, he can develop a port that works really well if he knows where he wants to put the air. I think the biggest attribute to that is actually valve jobs. So we flow test our valve jobs. I would say, like, we come up with a program, or we come up with a particular valve job for a cylinder head, but we only get there because, like, some valve jobs will kill the port 30, 40 CFM, whereas other valve jobs will pick them up 20. And you don't have to make it any bigger, right? Because we're just changing angles. I think that's where the flow bench kind of shines, where you don't have to put it on a car to know that it will pick up just from the valve job. Other things, I think if you really hone in on just a peak number, you're going to lose. You're going to be that guy that's like, who can talk proudly about his flow numbers, but he never outruns you.
Sure. So, I mean, you could relate it to maybe someone bragging about their dyno sheet that shows a peak value of 1,000 horsepower, but it's actually not making any boost until 7,000 RPM and really needs to run to 10,000 RPM. So on the street would be a complete absolute dog, but might perform on the drag strip. That sort of, is that kind of a good comparison?
Yeah, like, the guy he probably has the cams too big and the ports too big, so the car is real peaky. So it only sees. That's what I see on the flow bench. So if we go into a large valve, or we go to a big port, it flows really well. Like a big valve will only flow well over 350 lift. So after 350 lift, it absolutely kills the stock size valve, but it doesn't need to. Like, we're not going to run a cam that's that big, right? So it'll do the same thing on the dyno, where the car is going to be real lazy in the upper RPM band. I like to say it's almost like you're either going to build a mountain or a ski slope, because the mountain is going to be the stock size valve, smaller port, the right size cam, and they'll build a mountain of the dyno sheet. Whereas the graph, the oversized valve, big cam, big port is going to look like a ski slope. It's going to get that peak number, but it's not going to do anything anywhere else.
There's a bunch of stuff that you've already talked about that I'm going to go back and dig into, but just seeing as you've mentioned that. No, it's great stuff. I'm just trying to keep track here. Essentially, it sounds like what you're saying, though, is this all really comes down to choosing a package. And I say packages, it's not just the porting, it's the valve size you talked about, it's the combination of cam as well to suit your application, and what will work for a modified street application and be a really, really nice all-round driver, giving a wide torque curve and really good power, versus what you're going to want for an all-out drag application. They're going to be chalk and cheese, correct?
I kind of size them the same, to be honest with you.
Okay, interesting. All right, we can dive into that in a little bit more detail, because I do want to come back and talk about cams as well and how those relate. But before we do that, you mentioned the valve seats, and this is a topic that I hear talked about a lot, so I wanted to dive into that in a little bit more detail before we move on. So when it comes to the valve seat, we hear people talking about 3-angle, 5-angle radius valve seats. What do we need to know here about these valve seats and how that influences the flow? through the port.
I don't know where 5-angle became such a big number for everybody to. I get that all the time. Oh, I want a 5-angle, but so a lot of times a 5-angle on some valve seats are going to be a radius because there's not enough width to really run a 5-angle. I'm just going to go round numbers, right? It would be a 35 top cut, a 45-degree valve seat, which is where the valve is going to seat to, where they're going to mate. And then you're going to put 3 cuts underneath of that. Or some people add the back angle of the valve as an angle of their valve job.
Okay.
So it's not universal. It's something that I think is kind of a mythical figure that, people think are better.
Just another area where there's a lot of confusions crept in, and it comes down to the individual interpretation on what we're actually meaning.
Yes. I mean,
okay.
I tried valve 5 angles. I'm going to say maybe like 05, 06, somewhere in that area. And then we got away from them, and depending on the head, it's either a 4-angle or a 3-angle. I totally stepped away from radiuses. They just don't work. I've never seen them work. They might work on the flow bench, but they don't work on the car.
Interesting.
I've learned that, and I'm not going to try to give away everything here, but especially on the intake side, I see guys trying to use a radius on the intake side, and it just never works. Like, it will show itself on the flow bench though,
but not in real world conditions. It doesn't work.
Not real.
My layman sort of take on this: are we trying to improve flow by essentially having more angles right up to the point where there's no angles and it's actually a full radius, so that the airflow doesn't tend to separate and stays attached to that area of the valve seat? Is that the intention here?
Well, I think that's what happens, but it's not the intention. That's not my intention to do that. So I'm going to put a sharper angle on the bottom side of that, so that way we're going to separate it. It works a lot better, especially on the intake side. It likes almost like a ridge at the bottom of the valve seat. Some people would want to take it away, and I get that, but I used to feel that way until we quantified that it actually likes it. I don't know how to put that in layman's terms, but if you do a 3-angle or a 4-angle or 5-angle, some people request it, that this is what I want, and they don't really know what that means. And they don't know what actually works on their particular cylinder head. You're a Subaru guy. The Subaru, of all the cylinder heads that we do, they're very finicky on what angles you put on them. You put the wrong valve job on a Subaru and you'll kill the thing by 30 CFM.
Wow. If
you blend the valve job in, it will kill it and you won't get it back. There's no way to get it back. But we found that from the flow bench, and then we put it on cars, and we set world records and stuff, and we set a lot of world records with that kind of stuff. And we, because somebody says, I want this, we don't do that. We have the knowledge. We're the ones that went through all that, and we know. And it's not just how many angles, it's what those angles are.
Yes.
That really are what needs to happen, and the width of these angles is really what makes the difference.
Yeah. I mean, obviously there's a lot going on there in a very small area. One of the elements I wanted to dive into a little bit more was the actual width of the valve seat. So that's the area, essentially, I think you said at a 45-degree angle just before, where the valve is actually going to be essentially sealing against the valve seat when it's closed. Particularly for the exhaust valve, as I understand it, that's really its opportunity to dissipate the majority of the heat that's going to get built up in the head of that valve. So that's quite critical in order to keep the valve alive. So do you factor in, does it require a different width for, let's say, a modestly modified turbo street car versus maybe an all-out turbocharged drag cylinder head versus maybe a turbocharged endurance engine, which is going to get bashed on hard for 6 or 12 hours of racing?
Definitely, it gets totally different, actually, because I'll give you an example. White rice. I'm sure everybody's heard of white rice, or even Grannis. I guess we can talk about that.
Maybe for those who haven't heard of those two cars, just give us the quick sort of highlights of what they are so we can carry on with them.
So White Rice is a 2JZ 240SX. That's from Pro Speed Motorsports. Chris Delgado tunes it. It's Stewie Bowie's car. It has a 2JZ in it, and it's the fastest import on a 275 radial. He just went 419, I think, this past weekend in Georgia, but in the 8th mile, obviously.
Of course.
And Joel Grannis is one of the fastest 6-speed cars in the world. It's a 6-speed Supra. It used to be an IRS car, now it's a live axle. But we had an issue where we were bending valves. We went to bigger stems, we went to different materials, and we did all this different stuff. And it really came down to making we actually made the exhaust port smaller, and that picked it up, changed camshafts, and ultimately we ended up killing all the flow and just making the 45-degree angle almost as wide as the valve seat, just because we wanted to get the heat out of it. We could not get the heat out of that thing. So it has so much boost. I mean, we're talking about something that has 100 pounds of boost and a 400 shot of nitrous. It just doesn't care about the 30 CFM that you're going to lose from killing the valve job, but it does care about getting all that heat out of it.
Essentially, it doesn't really matter how much the port flows if you can't keep the valves intact because they can't get rid of the heat.
Right, because every hit, they would come back and, there would be a different cylinder that would leak down pretty bad, and they would just run it anyway. And the cars ran really hard with almost all the exhaust valves bent. And we've actually went well into sixes, like 650s, with all the exhaust valves bent. Now, a street guy would never be able to do that. The car would probably barely run. Don't get me wrong, this thing wouldn't start very well, but you get that thick up on boost and nitrous, and it sailed.
And enough boost and enough nitrous will fix a lot of evils then, by the sounds of it.
Absolutely. But it also creates a lot of evils. Trying to get the heat out of that valve it's been a real fight. We're getting the whole heat out of the whole cylinder head, because we started cracking them, and so we went to different materials, and I said, we're going into no man's land.
Yeah.
Nobody's really done this stuff. So we're trying to find our way through it, and we fail. And then we win. Sometimes, at least.
Yeah, it sounds like the usual story where you come up against one problem, so you sort of work out a fix for that problem, and then all it does is shifts the problem just a little bit further down the track, and then you start that whole process all over again. Frustrating at the time, but certainly satisfying if you can get to the end of it and work your way through all those fixes. And of course, when you're competing at that sort of level, that becomes some pretty expensive proprietary information that makes your product a little bit more valuable to the competition as well. Before we move on from the valve seats, in terms of physically cutting these, I mean, the old technique was to manually cut the valve seats. I can only imagine that as you sort of move on to more complex valve seat shapes, more angles, etc., this gets, I'm guessing, harder to do with accuracy and repeatability manually. Then, of course, there's CNC valve seat jobs as well, where I can assume that with the CNC equipment, the repeatability is almost guaranteed. Can you give us any feedback on this? Is CNC kind of the way, or can you still do a perfectly adequate job manually?
You can still do a perfectly adequate job manually. It really comes down to the user. If they know how to use a machine, you can be within, say, 0.003 of an inch from valve to valve. It just takes longer. And all that CNC stuff and that includes the CNC ported cylinder heads. It doesn't make it better. It makes it faster. It makes it incredibly faster. So, like, I don't have a CNC seat and guide machine at the moment. That's in the future, but in the moment, it takes us an entire day to do a valve job if we're going to put seats in something. Whereas if we had one of those CNC machines, we're talking maybe an hour.
Yeah, okay.
Maybe not even that.
Yeah.
But we're still accurate enough for, I guess, people tend to think that the tolerances need to be tighter than they actually are. Just like I said, I killed the flow and it was fine. You can be at that level. Things will work fine more than if you did it on a street car, because of what we're doing with it. And or also, you're going to find that things you would never work on a street car, like the bent valve thing, like, you're still just going to run it. Whereas a guy in a street car, he's never going to, he's not going to take his car out of his garage if the valves are bent. Whereas Chris Delgado's like, yo, we're going to run this thing. Let's just get it.
Yeah, competition will make you do things that you otherwise wouldn't, for sure. One other topic that always comes up whenever sort of valve seats and valve seating is discussed is lapping valves. And I think there's conversation sort of goes around, the old school technique, and I'm talking years and years ago, would be that you'd use a valve grinding paste and you'd actually seat the valve into the cylinder head and sort of lap it in, and that was how you were supposedly going to get a good seating of the valve, and it was going to guarantee it sealed well. These days, at least as I understand it, that's an absolute no-no. And actually, no, I have had my own experience with this. It wasn't actually on a cylinder head. Many years ago, I had a drag car that was running on, I think it was C16, so pretty heavily leaded fuel. It had sat for a long time after a race event, and anyone who's seen that fuel knows that it likes to attract corrosion, particularly in the exhaust system. And this resulted in an external wastegate with a fairly heavily pitted valve seat. And at the time, I actually tried lapping that using a valve grinding paste. And I mean, it's essentially just like a intake or an exhaust valve, just on a much bigger scale. And that showed me firsthand that if you do that, what you actually kind of end up with, and I can't remember which way it goes, one side ends up convex and the other side ends up concave. So you kind of end up with this valve that seats really nicely, but only when it's cold. And as it heats up and expands, you're almost guaranteed that the seating is going to be affected. So my take on it, my understanding is that's why it's sort of a no-no valve grinding jobs on modern cylinder heads. We don't do that. But in terms of using a light lapping to see a contact pattern between the valve and the valve seat, what's your take on that? Is this a technique we can use? Is that still a big no-no?
Oh, it's an absolute, you could absolutely do it, but don't think that because you lapped a valve in that is a quote unquote valve job.
Sure. Yeah.
Right. So some people, they'll take a seat that's like, say, 10 or 20 years old, and they're going to take their brand new valve and they're going to lap it in and it's going to be perfect. That's not the case, because normally, and I'm saying this like on most high performance cars, those things have been beat on.
Yeah.
And now the valve seat's going to be out of round, it's going to be rounded, or it's going to be beat in. There's a lot of directions that can go. And then they just lap a valve in, and then I see people filling it with gasoline and, like to check if it's leaking. And reality is that you can still lap the valve in. We do it every day to check the contact patch. So when we're doing a valve job, we'll lap one in, make sure that it's where we want it to be on the valve, and then we do our valve job. But I don't see any issue, as long as you're clean about it, that you can clean all of the valve seats and clean all the valves. But you want it on a fresh seat. You don't want it on something that's used and beat to hell.
I'm guessing if you're using it on that old beat to hell seat that's out of round, even then though, a light lapping is going to show you that you're not getting good contact all the way around the valve seat.
Yeah, but who knows what it's supposed to look like?
Fair.
Right, a guy who sees them all the time, I'm going to look at it and say, "Oh man, look at your dark spots, look at your light spots," and that's not gonna really work for you. But most people are going to look at that and just see a line that goes all around it, because if you were able to keep the valve in one spot, and when I say that, it's like because you're rolling it in your hands, and if you can keep it in one contact area and it's dark all the way around, that's when you know you're good. But if you see any light spots, that means that it's not round, and you just kind of just drug the material of the lapping compound with the valve, and it's just not a true story.
Okay. I feel like we're getting a little away from the core of porting, and we are going to get back to it. But while we've gone down this rabbit hole of valves, I think it's probably also worthwhile talking about valve sizing. And yeah, again, we live in this world where big is always better. And a lot of the valve manufacturers for popular engines will make a 1 millimeter oversized off-the-shelf valve, which in general can be made to work with the stock valve seat, hence reducing the cost and complexity in terms of fitting them. So I guess the first question is there always a valid argument for going to an oversized valve, or is that not always going to give you a benefit? And going hand in hand with that, just physically fitting an oversized valve, is that going to give you the advantage, or is it a case of keeping a relationship between the valve diameter and the throat diameter of the port?
So I always have a argument of why not to go to the oversized valve. So like a Subaru, a lot of guys put oversized valves in the Subaru, and on the intake valve, the 45-degree angle is now 4 thousandths. Like the valve is 4 thousandths smaller than the valve seat. A valve seat is essentially a heat exchanger, or like a heat sink. So if you take all that material away, now you just took away your heat sink. You're not going to get the heat out of the valve. I think it's okay if you're going to do an oversized valve and a valve seat, possibly. But on the flow bench, and I've seen on the cars as well, is that they do flow better, but they flow better from 350 lift on. So you're always going to have an advantage if you're going to look at the big number. Like if you're going to look at a high lift number, you're going to say oversized valve always kills it. That's 100%. You'll never see a stock size valve outflow an oversized valve in high lift.
But just not through the lower lift areas of flow.
Yeah, from 100 to 350, it's going to demolish it. And we're talking 30, 40 CFM. And this is like on average, every cylinder head we do, it's about 30 to 40 CFM better on the stock size valve to 350 lift. And then 350 lift on the oversized valve just takes over.
Interesting. I would not have guessed that.
2Js are like that. The Mitsus are like that. Like the 4Gs are like that. Now the Evo 10, like people sell oversized valves for the exhaust or, for the Evo 10, but they actually don't even fit on the exhaust valve, like on the seat. Like it's bigger than the seat. So
you have to do a seat to actually fit them.
That's the crazy part. And I'm not going to name names. There is actually a commercially available, huge, known in the market shop that sells a Evo 10 with a stock or an oversized valve, but they didn't know that it doesn't fit on the valve seat. So nobody measures this stuff. And it doesn't flow better. It actually hurts the flow. So a stock size valve, and we've went up to 2 millimeter over on the Evo 10, and it actually hurts the flow. Anytime we put a bigger valve in the Evo 10, it hurt it.
In terms of the other examples you gave, though, where you're really only seeing that benefit above, let's say, 350 thou lift, am I right in saying it's therefore going to be pretty hard to justify that bigger valve for a lot of applications?
Almost everything. Like we don't put...
Yeah, okay.
I try not to put an oversized valve in anything we do, to be honest with you. And that goes up to like 2,500 horsepower, like the 2Js. We set world records with stock size valve. Joel Granis has a stock size valve. We ran stock size valves in white rice for a little bit. We mostly ran oversized valves in that car, but we also did stock size valve.
So this sounds really like a marketing ploy that works on in a desire for bigger numbers and everything, including our valve sizes.
By saying +1, you're saying I did everything I could do to that head, but you did everything wrong. So that doesn't really help you. I mean, that's just like
it only really counts when you're doing the right things.
Yeah, I mean, maybe we're a little different, and I'm willing to go out there and just we sell it one way. Like people come to us like, I bought these parts, and I bought this oversized valve. We just won't install it because I know that it's not going to help you. It's going to hurt you. So there's a point of diminishing return that you can't get back if we you can take it out, but you can't put it back in. So you're going to be completely unhappy, and you're going to pay me for it. But you don't know that.
And ultimately, that's going to end up hurting your reputation as well. You're providing a product that's not as good as it could be.
Exactly. And I think that's why Head Games has such a good reputation, is because we don't do that. We don't just do what this is not Burger King. You can't have it the way you want it. It has to be our way.
Yeah, well, I mean, I guess if the customer knows more about what they want in their cylinder head than you do, perhaps they should be in the head porting game in the first place.
Yeah. I mean, if you've had 20 years of experience of like setting world records and porting heads and going on the flow bench, then, maybe you should work here or we should be working for you. But, I get it, because most of the market is geared towards that, that marketing ploy.
Yeah.
I get it. Maybe we would be rich if I went that direction, but, I don't think so. It goes against anything I can't bring myself to do that.
Yeah. Let's just come back and something we'd already just touched on, but we'll dive into it in a little bit more detail. Again, this is a little outside of the realms of just head porting, but I know that all of these elements come together and you have to consider the entire package, not just one part of it on its own. So this is the selection of the cam profile, and then of course the springs that go along with that. And again, I've seen this through my old shop, and I guess I've probably been guilty of it in the past as well. When you're looking at any cam manufacturer's spec list for a particular engine, and they might offer 6 or 10 different cams of different grinds, and they get progressively uglier and nastier the further you go down that list. So, I mean, when they're all, for the most part, the same money, it's very tempting to just go to the bottom of that list right from the get-go and pick the biggest, ugliest cam that they offer and put that in your engine. That's not always going to be the best way.
That's 100% not the best way. You really need to size it right. And the problem is, there's actually a few problems with that. So if you're comparing camshafts we're just going to sport compact stuff, and I think that's our main audience here, is that, so you have one manufacturer that measures it in imperial, and then everybody else is in the metric system. Brian Crowder sells everything in imperial. So you're looking at durations, and everybody's looking at the advertised duration. Nobody's looking at the cam card. They're not looking at what it is at 50, which would be Brian, or 1 millimeter, which would be everybody else. So nobody even knows. They're just saying, oh, I want a 272, or I want this 264. They actually don't know what that means. Like, that's like a pie in the sky number it's an advertised number, and you don't know really what you're purchasing. You just say, I need that. And I think that camshaft knowledge is really missing in our whole industry. I don't think there's very many people who really know what to buy. They just know that their buddy bought it. It's kind of like turbocharging. Like, a lot of people don't read a compressor map. They don't know what to buy. I don't either. I don't know anything about compressor maps. I just call Jeff Racer. I just call Full Race and say, what do I need? But it's the same scenario where you don't know how to read a cam card. So you just buy what your buddy bought. And your buddy probably bought the wrong thing because he just found on the internet, he found a combination that kind of works. And then they bring that stuff here, and I happen to know camshafts, and we won't install it because I ask you how much power you're making, because I feel a lot of people go off of the RPM, but RPM is a duration-based type of thing, and I think it directly correlates to how much power you're making. So you're not going to run something that has 240 degrees at 40 duration with something that makes 600 horsepower. It's just not going to happen. Although you might want to run 8,000 RPM or 9,000 RPM, which is what you need with that duration, you're buying the camshaft that is woefully too big, and you're going to make that peak thing again. So you're going to make that ski slope instead of the mountain. And we're trying to build mountains here.
Yeah, I think I've seen this time and time again with my customers that would come through the door for tuning work. And yeah, again, they go with a cam that's way bigger than what they need for their power aims, and all it does is result in a car, particularly for a street-driven car, is just an absolute dog out on the road and really doesn't perform until it's right up in the rev range. And then often the rest of the engine package can't actually support the rev range that the cam really wants to be efficient in working at. So yeah, I think the key there, and again, we've sort of got a little outside of head porting. I think the key though is to understand the entirety of the package that you're aiming to build. In your instance, it sounds like the best place someone could start before they purchase a damn thing is to come and talk to you and say, hey, look, these are my aims. And it sounds like you can probably recommend that entire sort of upper engine package that's going to support their aims and give them the best results while achieving those aims. Is that a sort of about right?
I'm not saying I'm the only one that you could talk to, but
Of course.
but I think that you could go off of our price list. Like, you just go on our website. You don't have to talk to anybody. So all of our pricing is separated by wheel horsepower. And I do that because, from my experience, like a certain power, it's not a small block Chevy where you have like 1,000 different cams and 1,000 different stuff. You know, I put together some packages that I know work. I know it leaves some of the manufacturers out of it just because we can't add everybody's stuff. And we have our favorites. And we know that what works and what doesn't work.
Yeah, I guess the old story, if it isn't broken, don't fix it. Once you know what works, rinse and repeat.
Or when it's broken, you fix it, right? Like, if you know that a certain manufacturer, you know, their stuff's not so good no more, right? So then, you know, it used to be great, and you have to move on from it, and you have to change your pricing, and you don't recommend it as much anymore, and you find the next best thing.
I just wanted to take a moment out of this podcast to talk about a course that we offer that's really relevant to today's topic, and that is our How to Degree a Cam course. Now, when it comes to ported cylinder heads, obviously a common upgrade to go along with the head porting is a set of larger, more aggressive cams or camshaft, depending on your particular engine setup. And in order to get the most out of your aftermarket cam or camshafts, it's essential that these are dialed in or degreed accurately. If they're not, then the intake and exhaust valve opening and closing points aren't going to be where the camshaft manufacturer expected or intended them to be. This could result in less power and torque than the cam is capable of delivering. It could move where the power curve is in the rev range, or worst case scenario, you could actually end up with expensive valve to valve or valve to piston contact. Obviously, no one wants that. Our course will take you through the entire process. You'll learn about the different types of valve actuation we see across different engines. You'll learn some of the practical skills such as how to correctly find top dead center, how to use a degree wheel, how to read a degree wheel, and how to read and understand a camshaft spec card. Then we go through the process of actually degreeing your cam or camshafts accurately. This course is generic, it's important to mention, so it'll work irrespective whether you're working on a basic pushrod V8 or maybe a quad cam V12. It really doesn't matter. The principles are exactly the same, and we offer a very simple 6-step process that you can follow to make sure that your cams are degreed absolutely to perfection. And again, the 6-step process applicable to any engine. By breaking it down into these 6 steps, each of the individual steps is quick and easy to complete, and at the end you've got a correctly degreed engine, and you're going to know that when it comes to starting that engine, the camshaft and valve opening and closing events are exactly where the manufacturer expected them to be. Moving on from this, we do also include a library of worked examples in the course where you can watch cams being degreed from start to finish following that 6-step process. If you're interested in learning more about this course or enrolling, we will put a link to it in the show notes. Let's get back to our interview now. Let's move the conversation back more specifically to the head porting. And I guess, in terms of the restrictions in a factory port, the areas that are a shortfall that in most instances there's going to be some room for improvement, what would these be?
When it comes to, well, really it's just a bowl area. I mean, that's like, or the throat diameter, like we spoke about before, is going to be 80% of what you're going to find in most street cars, up to like 800 to 1,000 horsepower. Putting the right valve job on it, sizing the throat diameter correctly, and blending in the short turn and the bowl area to that, putting a bronze guide in it, a stock size valve, and some good valve train is really where all the meat and potatoes are.
Okay. So let's dive into a couple of those. When you say, just for those who maybe aren't picking up what you're putting down here, when you use that term, the bowl area, whereabouts are you actually referring to more specifically? Unfortunately, we don't have the benefit of a nice photo or diagram that we can point out.
Yeah, so you're looking at, say, 350 thousandths or 250,000, a quarter inch below the valve seat is what I'm talking about. So that area in any cylinder head, I don't care what it's on, that is the most crucial area to get right and not make it as big as it can be. It goes along with the port, because if you make it too big, you're going to hurt it. But if you size it correctly, and sometimes those percentages change per cylinder head, but if you're able to size it correctly, do a short turn, and there's 40 CFM just in that area. Sometimes what people pick up like fully porting a cylinder head, they pick up 40. So if you can make something it's a cost-effective way. This is something that I brought over from the domestic side. When I worked for Muses, we did a lot of pocket ports, and in 08, I almost lost everything we owned. So I started doing pocket ports. We started going on the flow bench, and I just started flow testing stuff and started flow testing valve jobs and try to come up with a good package to the Sport Compact, because it really wasn't around. You never really ever heard of pocket ports. So we came up with them for a variety of different cylinder heads. And I said, it's just something that pretty much anybody could do. They would just need to know what size to make it. But that's the most crucial area to do.
It sounds like that pocket port, you're sort of applying the 80-20 rule there, and you're sort of getting 80% of the benefit of a total port job and the entire cylinder head,
yeah,
but for a relatively modest amount of actual investment and time.
Yeah. So for the pocket port itself, it's $250. That's what we charge to just do that area.
Wow, that's pretty cost effective.
It's very cost effective. Don't get me wrong, there's other things that are involved there, because you have to do the valve job. We only do it with valve guides, because to do it the right way, you got to knock the guide out. in order to get around and shape it correctly. But for the and also because we're going to be putting aftermarket valves in there, and you want to size the guide to the valve.
So this brings up another few. Every time you answer one question, I feel like there's another 5 hiding in there that we need to dig into. But let's do exactly that. It's great stuff. So the valve guide, which I mean, I think probably most people listening would understand what it is. But the guide, as its name implies, is there to guide or support the valve, and it projects out into the port some distance. And these factory guides are normally pretty chunky little fellas, and I don't know, from just purely looking at these, I kind of get the sense that they must have some negative impact on the flow. The air probably isn't necessarily going to want to nicely flow around them. So the first part of that question is A, am I right there? B, when I see solutions to this, I've sort of seen 2 styles. Quite often we see the guides basically knocked back to the port wall, so there's no protrusion out into the port at all. Or alternatively, I've seen them sort of, I guess you'd call it teardropped or profiled to sort of help flow. So what can you tell us about that?
So yes, it doesn't like to flow past it, but we're talking maybe 5 CFM.
So a minor evil, really.
It's a minor evil. When you think about the problems with getting rid of it, or the problems with bringing it to the roof of the port, or if we're going to teardrop it, I'm not familiar too much with the teardropping, but
streamlining it, I guess you'd call it.
Yeah. I feel like I've seen it, and we just never do it. I like to run the full length of the guide, the full width of the guide. You can put some taper to it to help it somewhat with the flow, but there's not enough there to put all your efforts into shaping this thing. If you get rid of it, or if you do what I'm, like we're teardropping or taking to the port, now the valve is unsupported. And I don't really do enough all motor stuff to know if it's a problem in that arena. But I know on the boosted side, if I have a valve that's not supported, it's going to move around, and it's going to wear the guide out prematurely, and it's going to bend the valve, and it's going to beat the seat up, and it's just going to create havoc. And now the guy's coming back at me with a head that needs more work. And, I get that, maybe they want to make more money, but like, I want to sell a reliable product that doesn't have that kind of situation going on when I know I can absolutely stop it from happening.
Yeah, it makes a lot of sense. I guess it's easy to look at that small improvement. You mentioned maybe 5 CFM, but it's easy to overlook all of the downside implications that grinding that valve guide back against the port wall is going to result in terms of premature wear and the extra servicing that head's therefore going to require to keep it operating where it should be. I think it's worth also mentioning that if you, again, we can't show these, but if you look side by side with an aftermarket bronze guide versus maybe a factory one, you've sort of mentioned there the taper, but quite often there will be a taper towards the end of those bronze guides compared to stock. So naturally, they're going to provide a little less, I guess, surface area to airflow restriction, I guess that results in compared anyway. And in terms of that, since I just mentioned that, factory guides versus an aftermarket bronze guide, why do we go in that direction? What's the benefits of going to an aftermarket guide, other than maybe that taper that I just referred to?
The taper, I have never flow tested one back to back, so I don't know if the taper actually is worth anything, but
got to be pretty minor though, right? If anything.
Yeah, I mean, if it's 5 CFM for the whole thing, but maybe three, but the attributes of a bronze guide is it has natural lubricity, because now we're talking about bronze, so now we have less friction and it doesn't break. At least more often than not, it won't break, because a steel guide's gonna, like sometimes when a valve bends, or we're talking about it moving around and wearing the guide out, it will break the top of the guide off, and that's going to go in your motor. Whereas bronze is just going to wear, and you don't have to worry about it in that way. And the other attribute really is when we're going to an aftermarket valves, now we can resize the guide to the valve. So a steel guide that's made for a factory valve, most aftermarket valves, they're smaller in diameter. And then we're only talking about maybe a half a thou, but a half a thousandths in valve to guide clearance is actually a pretty decent sized number. So if you run an aftermarket valve in a steel guide, you're running in that same situation I was talking about, where it'll wear the guide out prematurely and it's going to beat everything up. besides a Manley valve, so the Manley valve is probably the bigger of all the stem diameters, but all the rest of them are a little bit smaller. I think there's very few that are the same size as a factory valve. So now we can resize the valve. We can run a tighter clearance because on a steel guide you can't run. You have to run a very large clearance for valve to guide clearance. So now with a bronze guide, we can run a thou, whereas a steel guide you're at like almost 2,000s.
So that's going to provide better support for the valve. It's going to not wear that guide as quickly. That's kind of the upsides of that.
Very good, yes.
And I guess control how the valve's seating more accurately as well.
Exactly. So everything's going to wear much better with a bronze guide versus a steel guide.
In terms of the compatibility as well, as I understand it, that lubricity of the bronze guide is really important when you go to the likes of an aftermarket stainless steel valve. If I'm right, as I understand it, there can be compatibility issues with a factory steel guide with a stainless steel valve, and that can result in galling. Am I on the money there, or is that not correct?
I've never heard that, but I think what you're talking about is saying like the valve's smaller. The stem size is smaller.
Sure. Yeah, okay. Yeah.
So it's going to just rub. It's going to move around. It's going to be like a hot dog in a hallway in a steel guide. And you really want something a lot tighter. And most guys are not measuring their valve with a micrometer and then taking an inside mic and measuring the inside of their guide to see what size it is. They're just sticking them in there, and now you have an issue with galling. The only other issue could be, I said, a Manley valve's bigger. So if they're not measuring it, now it's tighter. And when you run a tighter valve, you're definitely going to run into some issues there with galling.
All right, moving back to other terms you use, the short turn radius, which again, we can't point out, but I mean, hopefully the name is pretty self-explanatory. How does that sort of rate in terms of the importance and the rest of the port? You sort of mentioned that bowl shape and size is critical. The short turn radius, getting that right, what's that sort of give us?
That's all of it. Getting the short turn right, so if you take out too much of the turn, you're done. If you change the shape too much, you're done. You almost can't get it wrong. If you get that wrong,
everything's gone.
It kind of goes along with the same thing I was saying with the size of the bowl. Like if you make the throat diameter too big, it's gone. But the short side, I would say that's more important than even that, than getting the size right. If you wreck that short turn, then it's done.
What I'm kind of picking up as we're going through this is there's a heap of places to destroy everything, and a lot where you need some pretty specialist knowledge in order to see the improvements. Is that fair?
Yeah, I would say, I mean, we have a ton of videos on YouTube. I'm trying to give all this stuff away for people to listen to and or watch. And yeah, there's a ton of places that you can it's very easy to destroy it. And it's things that people do every day. It's things that we see come in every day that are destroyed. Like there's no way we can get it back. And people are like, oh, can you do this? And I'm like, yeah, but you'll never flow well. There's nothing that we can do at that point to make it. I don't care who works here, what CNC it goes on. It doesn't matter. It's just never coming back.
Unless you throw it away and start again with a fresh casting.
Yeah, unfortunately.
How about other elements like the port divider and a 4-valve head? Obviously, we've got a divider between the two valves from where the port goes down. We often see in a ported head, those are knife edged. How important is something like that, or does this become sort of as much aesthetics as anything?
I mean, we try not to knife edge it. It's also a very important area because a lot of people want to make that as sharp as possible. And that's where you're going to lose flow. Again, you're going to ruin it because you want to blunt it. If you don't blunt it at the very end, you can almost make it as thin as you can. That doesn't matter. But then again, it does because it goes all the way up into the throat area and you end the short side. So like I'll widen it on the short side, and it doesn't matter so much how thin you make it until the divider, and then you want to blunt it. If you don't blunt it, it actually... Well, I should say there is hidden flow. So it won't ruin it. There's just more flow if you were to blunt it. People look at it and they think, oh, that looks kind of funky because you just squared something that you made completely sharp. But it works. It works very well.
How about the actual surface finish? On face value, I would have thought initially, back in my earlier years, that a mirror finish on the port wall would have been the ideal. However, the more I've learned, there's sort of some quite tricky interactions between the port wall, and this sort of really probably comes down to aerodynamics in a wider sense, and the boundary layer of gases that sort of sit there against that port wall. So is a slightly rougher surface finish actually desirable on the port wall as opposed to a complete mirror finish polish?
Absolutely, because so the problem is that you make the air move so fast if you mirror polish it. You're making the air move so fast that the fuel falls out of suspense and it'll puddle. And then you can't tune it. You're not going to do anything with it. I mean, it's just going to be a mess. I feel like for whatever reason, that theory has gone on since the 60s. Like cast iron heads were getting mirror polished with carburetors. And up until today, people are still doing this. But what is never worked throughout history? Like nobody's ever done it. So I don't really understand where it started, but you definitely want to have like, so we do a minimum of 60 grit. You can do 80 grit. I wouldn't go any more than 60 grit or 50 grit. I would say if mirror polishing was so important, then there would be no CNC heads.
Sure. Yeah, I mean, that's a good point. If you actually look at the finish that comes off a CNC ported head, it's far from smooth, isn't it?
Yeah, I mean, you could slow the machine down. You could get a somewhat mirror finish, which would take forever, but
no one does that.
But no one does that. And don't get me wrong, partly is because a CNC machine, when you get a head CNC, it's really just to make it faster. It's not to make it better. It's just because now we can repeat it very quickly. To think that we need a mirror finish for just the air, so you're only thinking of one element, and there's two elements going in there. What I don't know, because I haven't dived deep enough, is on the DI stuff.
I was going to bring that up, but I guessed maybe your experience wasn't in the direct injected side of things. So yeah, fair point. It'd be interesting to get some more information on that. I kind of wonder if that mirror finish styles really come from a layman's perspective. The smoother it is, you would think on face value, the better. Plus it gives you something, there's a visual look. You know that if you've sent your head out, spent a bunch of money on it, it comes back and the ports are all mirror finished. Well, clearly someone spent a lot of time on this, so it must be good. And I think there is an element of that, being able to visually see where our money's been spent, makes us feel good, rightly or wrongly. Maybe the dyno doesn't back that up, but if we feel good about it, then happy days. On the same note, I've seen this around a bunch of times. I think I talked to you very briefly about this when we caught up at Texas 2K a fair few years ago, but dimple porting. And this is sort of a technique I think has come about with the adoption of CNC porting. And for those who haven't seen this, go Google an image of it. But essentially it looks like the finish on a golf ball being applied to the inside of a port. I'm interested to sort of talk a little bit about that. What's your take on this? Is there actually a benefit in it? I mean, the cylinder head obviously is not a golf ball, but does that same technology that works for a golf ball flying through the air apply where air is flowing through a cylinder head port?
We actually made a video about this on our YouTube where I took a regular port and a golf ball port and I threw it off our dock to see which one would go farther. And actually the dimple port won. And I didn't even, that wasn't even trying to push it harder or anything. The dimple port actually won. I think it's a big gimmick. I think that, well, actually, I know that there's only one CNC machine that does it, and that's a Rottler. The Centroids don't do it. None of the DMGs, none of the good CNC machines do it. I'm not saying that Rottler is not a good machine. It's a great machine, but there's only one machine that does it. Somehow, some way, somebody thought that if I can make it do dimple ports, it'll sell more machines because it's a gimmick that people can put on their head. But as a guy who's so deep into racing, I've never been outran by one that said, man, that dimple port just totally changed my life. It's just never happened. I've never seen it. I can't wrap my head around how it could, like, I guess it works. Like you could drive it, but I don't see where it's a benefit.
So one of those areas where just because you can do something doesn't necessarily mean you should do it.
Oh, 100%. And I know there's some shops, I'm probably hurting some feelings right now, and they're saying that guy is such a dumbass. He doesn't know what the hell he's talking about. But I mean, if it's possible, like we can not put them on the flow bench, like let's put them on the car. I mean, I'd love to be proven wrong in this aspect,
Yeah,
but I just never have seen anything great come out of a dimple port.
sure. It's not something I've personally had experience with, so I can't talk to the pros and cons of it. I have seen them out there, mainly on social media, and I've always wondered what the fuss was about.
I think that if we all had carburetors, it would be a different conversation because a carburetor is going to need the atomization of that dimple port, but we have a fuel injector. So, like, where is the? I just don't see the benefit when we have an injector that does the job that they're talking about it doing. Like, does it atomize it better? I mean, you're going to tell me you're going to beat an ID injector and atomizing a few? I just don't get it.
All right, we've talked so far a couple of times about CNC equipment, and that's something that I've seen become more prominent. They're still relatively rare here in New Zealand, but all around the world, they've kind of taken over the game of head porting. And you've sort of already mentioned that they're not necessarily going to do a better job. They're going to do the job faster. And obviously, they still, you can't just feed a cylinder head into a CNC machine and go press a button and it's going to port it. It needs to be told what to do, which is generally digitizing of a hand ported cylinder head anyway. But I'm interested, are you still hand porting all of your heads? Are you relying on CNC porting technology? Yeah, what's your take on this?
So we have totally gotten away from doing most of the hand porting stuff. The shop's just too busy for, especially just for one guy. It just gets to be too much. We can't do it fast enough and we can't compete price wise. So what we did was I really want to get into a CNC machine, but we didn't have the cash flow to show it. So I guess I had to bite the bullet because I was really afraid to let our ports out, but I had to. So we picked a couple shops that we trusted. I kind of looked at what do they already have a plate for it? Do they already have a port for it? So that way we didn't have to pay for the plate. We only have to pay for the digitizing. And we had most of our ports now are CNC'd. So I'll hand port it, I'll flow it. We do the whole valve job, make sure that everything's correct, knock the guides back out of it, ship it out, get it digitized. It comes back. We flow test the CNC port because now we can flow it, test against the CNC versus the hand port, make sure we're on point, and then we okay it or nay it. Sometimes they have to go back and forth. Sometimes we do a lot of revisions. The 4G was actually the hardest of all of them that we've done. There's like 4 revisions in that one because when you go to a CNC port versus a hand port, like I know where the port is because my hands are on it. Whereas a CNC doesn't know where the port is, it just knows where it's supposed to be. And there's a lot of core shift in a 4G. So we were putting holes in heads. And some of them would leave here. Like you didn't see a hole. There was not like you could pressure test it, there's nothing going on. You start putting 50 pounds of boost at it, it blows a hole through the exhaust port. And it's really just because the port it's the head. It's not us.
Just too much inconsistency on the core shift across that particular casting.
Yeah, it's just that one casting. It really kicked my butt. We actually had to keep shrinking the exhaust port to a point where it flows decent. It could flow more, but the cars haven't really cared. But more importantly, the people care that they can have a head and it doesn't put a hole in it.
Yeah, that's pretty important. I've actually been down that exact path with the customer's 4G63 drag engine that was hand ported by a shop here in New Zealand, and it was a very, very frustrating experience because as the engine builder, it obviously became my problem as well, and that's quite a hard one to come back from, unfortunately.
Yeah, I mean, hand porting, I hand ported those things for 10 years and I never put a hole in one. CNC'd, the first one that came back had a hole in it. So, and it was rail in the short turn. So then we had to, I had to go right back to the drawing board. And thankfully, at the time we did it, those heads weren't so expensive as they are now, but we were able to, and they were very plentiful. But, to go so long, I'm thinking, oh, this is easy peasy. I've never put a hole in one. And then every one that came back was a hole. And some people say, oh, well, you took out too much. And reality is like, I've been porting that same port for 10 years. I know it measures. So no, I didn't take out too much. It's just the core shift is terrible. Sometimes we get back two JZs too. Two JZs, sometimes half the port is not ported because the core shift's so bad that, you'll have like port 1 and 3 are completely done and 2, 4, and 5 are not. And it's just, and then you're going to go back in there by hand and try to blend them all in.
Okay. A couple of elements that I wanted to dive into on this. First of all, you sort of talked about getting it digitized and then a test CNC port done and kind of validating that on your flow bench and going backwards and forwards. Once you sort of got the final result that you're happy with, where do you sort of get to from the CNC ported head and flow versus your hand ported? Are we talking within sort of a percent or better, or is it a wider variation than that? Does the hand port still win out?
The hand port will always win out because really the hand port wins out just because it's going to blend better. And it's really, I think any competent hand porter or head porter can pick up a CNC head, any of them. Like it just, as long as they're good, they're going to be able to easily pick apart that head and pick up on it. Again, it's partly because we have to size a CNC head to work with the casting. Does that make sense?
Yeah, it does. Yeah, I understand. What about in terms of consistency port to port? Is it a case of, if you've got a head, notwithstanding the core shift that you've already talked about and inconsistencies there, is it a case where you can hand port one cylinder of maybe a 6-cylinder head and then digitize that port and apply it to the other 5 cylinders, therefore, in theory, having 6 cylinders with the ports flowing absolutely identical? Or is that sort of fantasy land?
That's fantasy land. That's total fantasy land.
Good to know.
Yeah, because like if we were dealing with a billet head, we wouldn't have that issue because they can all, or if it's a cast and it was casted small, say like a trick flow cylinder head, trick flow casts all their cylinder heads small so that when they CNC them, they clean up and they're all the same. They can all flow the same. Whereas in the sport compact side, we don't have that luxury. So they're not casted small, they're casted to size. And then we go in and try to CNC them, and then they're all over the place. And that's what I hear a lot, that like if you get your head CNC'd, it's going to be more accurate. You're dealing with an accurate machine, I get you, but you're not dealing with an accurate part. If we're making widgets, we are. But when you're dealing with a cast piece, it's completely all over the place.
Okay, so you can only really achieve within the limitations of the raw casting that you're dealing with.
Yeah, and that's why I said like we'll go in and blend it all in and make sure that they are all the same. But that doesn't come out of the machine that way.
Yeah, that probably brings me to my last point, because if anyone's seen a head that's literally just come off the CNC porting machine, it's got a very distinct look in terms of how the port is being cut. And I've wondered to myself, and it sort of comes back to that previous point we were talking about the port finish, and you mentioned sort of around 60 grit is your happy place. Is there a benefit in hand finishing a CNC ported head? Is there further gains to be had, or are you starting to get down into that realm of diminishing returns? And what I'm talking about here is smoothing out those ridges and cut lines from the CNC tooling and manually sort of blending that in.
That's a total waste of time.
Okay, well, that's great to know.
Yeah, we'll blend a head in, but I'm going to blend it in with a grinder with a carbide bit, and I'm definitely not going to go in there and sand the whole thing. That's a total waste of time. If we could sell a hand-ported head without sanding, I would love that too, because I think it would work out great. But I don't think the surface finish is really worth the effort of going through all that.
Okay. In terms of that process, I'm just interested in finding out what actually goes into the digitization process. And I'm guessing that's something you're outsourcing anyway, but can you talk us through how that's done?
Yeah, so we'll take a head and we flow it stock and knock the guides out of it. And usually I'll make it so like I can take the guides in and out of it and pretty quickly, because it's gonna see the flow bench a bunch. So we'll fully port it, unless it's a head I do a lot of. And usually that's the only time we're going to digitize something, because it gets costly. It's like $3,000 to $5,000 to do something like this in each casting. So we're going to knock the guides out. We fully port it, put the guides back in it. I'll flow it without the valve job. I'll flow it with the valve job. I'll flow it with different valves just to see what the package is going to be. And then knock the guides back out of it. We send it to the company. If they have to make a plate, they'll make a plate that fits in their machine. whether it be a Centroid, or right now we're trying to deal with only people who have Centroids because we plan on buying a Centroid.
That plate you're referring to, this is a fixture plate that physically bolts into the CNC and the head bolts onto that. So the head is always in exactly the same position. Is that what you're meaning?
Correct. So that way they can indicate where the head's at, and they do it every time. They're going to go off of the dowel pins. So now the machine is going to go in with a probe, and it's going to probe. You can actually program it for how many points that you want it to hit. So that would depend on how accurate you want it, I should say. Like, so they make like a map of the port with the probes, and the machines, the Centroid and the Rottler, both do it automatically or autonomously. And then you basically have a map of the port. I'm sorry, I skipped a point. They have to use a like a putty, and they cut off half the port. And they cut off half the port because you're going to mirror the other side. So they're only digitizing the half of the port. They're not digitizing the whole thing. They just mirror the other side. But if it's a head like a 2J, now you have 3 different intake ports, 3 different exhaust ports, and none of them mirrors. So you have to digitize each one as like it's a different cylinder head. But most heads are not like that, and most heads you can just digitize. You put the putty in there and you digitize the one side, and it mirrors, and then you can just rock and roll through the whole thing.
Sounds like one of those situations. For every rule, there's always an exception as well.
Some of the heads are a real pain in the butt, and they cost a lot more to deal with. But I mean, that's the nature of it, I guess. As I said, you're dealing with a casting, and you're dealing with, like the GTE head's not even my favorite head. So like, but we sell the most of it. We just have to go through it. Thankfully, at least not yet, I don't have to digitize that stuff. I don't have to deal with all the intricacies of that.
One element we haven't really talked about so far is on the other side of the port, which is the combustion chamber. And quite often we sort of see the combustion chamber getting modified as part of an overall cylinder head porting. Is this something that you do at Head Games, or do you leave the combustion chambers mainly alone?
We do the chamber a lot on many different. So we sell, even when we're doing it by hand, so we do a pocket port R, which is where we do the pocket port that we talked about earlier, and we'll hit the combustion chamber. Or definitely when we're doing the CNC, we're always doing the combustion chamber. I'm always trying to get rid of hot spots. As a tuner, I'm trying to make it easier for you to add a little bit of timing, bring some EGTs down. I just want to make it easier to run a big number versus like having a lot of hot spots, and then you're worried about the control. Basically, you're trying to not have any, you put some timing into it, and then it's detonation sensitive. And I want to make it easier for the tuner, and that way he makes more power with a Head Games head, and he's going to love Head Games, and they're always going to make more power with a Head Games head because of those attributes.
Yeah. In terms of removing those sort of hot spots in the head, we're talking here about getting rid of sharp points and bits and pieces like that. Is that what you're sort of referring to, or is there something a bit more to it than that?
Well, I'm also reshaping it. I don't want to get too deep into the reshaping part of it, but we're going to reshape it for, obviously we have some flame travel to deal with. And I want to blend the top cut of the valve job into the combustion chamber because we're going to increase flow there. Because now, as I said, we're concentrated on that 100 number to 350 number. And if I can blend the valve job into it, now it's going to flow better at that 100 number.
How about, obviously this depends cylinder head to cylinder head, but quite often we see with some of these sport compact combustion chambers that the valves are quite shrouded, particularly around their outside diameter. And by shrouded, I'm meaning the proximity of the cylinder head for the first, I don't know, maybe we're talking 100th hour of lift, is kind of compromised by the proximity between the outside diameter of the valve to that part of the cylinder head before it clears that. Is the benefit to removing some of that material and essentially de-shrouding the valves?
Yes, exactly. We're trying to de-shroud the valve, so we can do it somewhat in the valve job, but it's easier. Now we can blend that all into the valve job, and we're going to de-shroud the valve, and then it increases airflow.
Okay. A last element, and I mean, hopefully I'm not sort of throwing you under the bus on elements you don't want to talk about too much here, but we quite often see on production cylinder heads sort of squish pads or quench pads, as they're kind of often referred to, cast into the combustion chamber. And I've sort of talked to about as many people who like to leave those as they are, as I have people who swear that removing them is the only way to go. What's your personal take on those?
I like them. I want to leave them in there. Like RV26 guys, I see that mostly in that crowd where they'll take it out and make it look like a big dish or a big bowl. And I think you just ruined the cylinder head. I did it one time for a customer that really, really, he was adamant about it, and I'll never do it again because you need that squish. You need that for, I mean, that's a flame travel thing. I mean, that makes the chamber work. So if you're going to remove it, I lay it back. Like I'm not going to make it a sharp edge. So I'll lay it back and make it so it's still there, but it's just not as prominent as it once was.
Okay. My understanding there is the intention is to help move the charge towards the spark plug, so helping to achieve a sort of a homogeneous charge and get that charge prepared right by the spark plug for the combustion event to begin. But I'm also definitely not a combustion specialist, so don't claim to sort of know all of the intricacies of that. All right, Dave, we are getting a little long here, so I think we'll start moving towards wrapping this up. It's been an amazing chat, and I'm sure we could probably go another hour, but we'll finish this up with the same 3 questions we ask all of our guests, and the first of those is what's next in the future for you and Head Games Motorworks?
So I kind of talked about it a few times during this conversation that we're going to make it more automated here. We're going to get a CNC. We're going to get a new one, CNC seat and guide machine. That was actually on the table like as COVID hit, and then things went crazy. It like blew up here. We're like, oh my gosh, we absolutely need it. But I felt like this wasn't sustainable. Like whatever the craziness that was going on wasn't going to be sustainable. And I know you're from a different country, but we have a president that I'm not very confident in, and he's shown me that it's going to cost me money. So I've been holding back. Maybe I need to get over that fear, but so far that is the future of Head Games. It's going to be to get a CNC seat and guide machine and a CNC machine.
Okay, that sounds exciting. Seems like a natural progression to take business to that next level.
Yeah, I mean we do about 120 heads a month, so it would be nice to not have to farm a lot of that stuff out, and it would make it so our turnaround times are faster. It is going to create a big issue because we already sent it all out, and now the heads aren't going to stop coming, and then we have a big learning curve with buying 2 new machines, and we're spending $500,000 on it, and then you have payments and everything else to deal with. It's a scary thing to jump into, but it's something that we're all very excited here about jumping into.
I guess the other element is, even when you are talking about work that's being produced on a CNC, if you're outworking it versus doing it in-house is always going to give you more control over the finished product, I would assume.
Yes. Yeah. I mean, I don't see too much, at least the people that we work with are great. And, if we say we want to change something, they change it. And then nobody's really bat an eye about it. It's just really, it's the timing, because like they're busy and we're making them even busier. Like we're not a slow shop. So, but the problem is that I guess I kind of messed up. So I went to Avenue to show a bank that, like, if you gave me a CNC machine, I'm going to make it work, because we're doing it by hand. It was really slow. Sometimes it would take months to get your head back. And so we started digitizing. Now things are coming back, within 4 weeks, but we could probably do that within a week if we had our own machine. But now we've digitized so much stuff, and now we're so much busier than we were when we were hand porting. We still would have to send stuff out. Like, we're going to get a CNC machine here, and we're not going to be able to just like you said, we're not going to be able to press a button, just it's going to work. So that's why we're trying to stick to one machine. If I stick to the Centroid, I feel like then, and we talked to the guys who are digitizing them, and we're going to be able to get our ports on thumb drives and be able to almost plug and play.
Okay. All right. Next question, David. Is there any advice you'd give to a younger version of yourself, given your career so far, that would maybe help fast track where you've got to and maybe avoid any pitfalls?
There is something that I dealt with throughout my career. It's really like dealing with like my people. So you mentioned like a pitfall or a pothole, right? So like A pothole is like a crack in the road. The water gets underneath of it, and then it eventually just gets bigger, and people start avoiding it. Some people complain about it, but most people don't. They just kind of, like they kind of go around it. And as the pothole gets bigger, people start hitting it. They start complaining about it, but they keep going. And sometimes they'll just keep going down that same road. And then there's other people who would just avoid it altogether. And your business is a lot like that, where if you have people complaining, if you have people who are not fixing the road, eventually those people are gonna find a different road to go on. They're just gonna find a different path because, like, you're a car guy, you don't want to keep going down that same road because you're worried about your wheels or what have you. And I guess my advice is to fix the potholes. If people are complaining about something, you need to listen to what they're saying and don't just say, well, you're the only one complaining. You have to really look at what is going on there. Is that something that I can fix? Is it something I want to fix? And who else does it affect? Is it affecting everybody? Or is it just affecting this guy because he's an idiot? And I've had to deal with this with manufacturers. There's been relationships that have been severed because we don't have the same, like, they have these potholes and they're huge and nobody knows about it. But I know about it because I measure stuff and I deal with their products so much, and they just never want to fix it. And that's just a really bad culture to have in your business. It makes it kind of sick.
Yeah, I've seen exactly the same as well, and again, I won't name names, but it was a set of aftermarket connecting rods, and they're a reasonable quality brand as well. And it comes with a card with the big end and the small end weights and the overall weight of the rod. And we have a saying, trust but verify. And as part of my engine building process, I went through and weighed them all. And I mean, they're not even remotely similar to what's on the card. But I had 3 rods that were clearly from one batch, and you could actually tell that from the part number on the rod. And then one rod that was from a completely different batch. And I mean, the weight difference was massive. And again, just didn't match the card. So it was sort of like they just chucked some numbers on a card and sent that out with this box of rods, and no one's going to check. So happy days. And it's like, well, no, actually, I do check.
Yeah, and a lot of people don't measure. I don't know if you complained to that company,
I did.
and they might have dismissed it.
They did.
And I deal with that. I'm not going to name names either, but I dealt with a company who, like, we flew their flag pretty high, and their product, the dimensions got too big, and it wouldn't fit. The particular part wouldn't fit in the hole anymore, and I would complain. And this goes for actually a lot of the different products that they sell. Not only just fitting in the hole, but like the measurements were completely off. It would make my job harder, and I would be complaining about it. But I just got looked at as a complainer. But really, I'm one of the baddest dudes that you're going to talk to. You need to listen to me. Like, if I'm measuring something, I'm not saying anything that you can't just go into the back and use a Harbor Freight caliper and measure yourself, and I'll ship you ahead if you need that. But I kept hitting that pothole, and I lost customers over that pothole because we kept hitting it. And eventually, I just went in a different direct. I just went to a different road. I just couldn't do it anymore. But I feel like I stayed on that road too long because it was my favorite road, and I just kept wanting to go down that. It was easy, and I wanted to keep going down that road, and it hurt me.
I think this happens as well when you start working at a higher level, and all of a sudden the products that you used to be able to get away with. I mean, maybe there's been some shift in the quality controls at that company as well, but as you start refining and working at a higher level, all of a sudden some of the products that you used to use and rely on in the past maybe don't cut the mustard anymore for what you're trying to do. And it can be difficult moving on from suppliers of products that you've used for a decade, and then all of a sudden you've got to actually go and find someone else that, and it's the usual story as well. Sometimes it's better the devil you know than the devil you don't. There's upsides and downsides with all of this, but I mean, I think a really valid point that you make there.
Yeah, I mean, so this is a completely unrelated story. I know we're getting out of time here, but the NASA Challenger story. So I read a book that was the same direction, where the guy was complaining. There was an engineer was complaining about the heat shields on the Challenger, and he just couldn't let anybody hear him because the culture in the business was, it's okay, it will live. because that was what was easy. And he wasn't listened to. Challenger went up, came back down, crashed, right? Or blew up. And, everybody, the whole world got to see this ship go come apart. And it was all because the culture in the business was sick. Like there was a hierarchy, and there was nobody actually talking to each other and listening to each other, or listening to, and I said, it comes out to the same scenario here where, like, the company's not listening to me. I like to listen to my customers. Just if they have something to say and it's a valid complaint, I want to hear about it because I want to fix it. I don't want them to go somewhere else and say, "Oh, screw head games, they did this to me." Like, I want to fix it. I'm here for that. If I were to give my younger self, I mean, that's just one thing. There's so many, I really feel like there's so many lessons I learned over the last 20 years of being in business that, but keeping your friends, basically that's what the pothole thing kind of is like who you keep your friend. You want to have like-minded people in your corner. Like in my instance, I always try to make something better. Like, I don't care what it takes. I mean, that's how, if I stop trying to make this better, then I'm going to be done. I'm going to retire. I'm going to be, there's no way that I can continue on because I'm not learning anymore. I'm all right with failing. I'm all right with doing something wrong and I failed and I learned and I moved on, but I'm not okay with just, we're not going to do anything. I can't live like that.
It's interesting. I sort of saw that happen as I was getting involved in the tuning industry with some of the bigger name tuners that were sort of around me here in New Zealand, and admittedly they were quite a bit older at the time. And as I was sort of getting involved, why I really am still passionate about tuning is because there's always something new to learn. There's always new technologies coming through, and there's not a day I'm on the dyno where I don't learn something new. And I kind of that's how I feel I'll always go, and maybe it won't be, but these other tuners are sort of, I got the sense they got to a point where they got comfortable and kind of topped out and decided that they didn't really want to progress and push the boundaries anymore, and kind of keep abreast of what was changing in the industry. And over time that worked okay for a few years, and then slowly but surely they sort of fell away and a new generation of tuners came through. And I guess that kind of happens in a lot of industries. It's a personal decision as to what you want to achieve. For me, I'm always trying to stay at the cutting edge, but I guess at some point that's not always for everyone either.
Well, that's part of the way that I've able to keep head games relevant for the past 20 years. I don't think that it's not normal for a cylinder head shop to be relevant 20 years in the making, right? So 2001, we were doing stuff for R.S. Lanian, and we were doing Sean Glazier, and we're doing all these big names back in 2001 and up to 2007 when they stopped racing. But it never stopped. Like, I'm still dealing with all the top racers. We're still breaking records. We're still, if there was a championship to be won, we'd still be involved in that. And most people don't do that, and that's because, like you said, they top out. People top out. They kind of, or they tap out. They don't really want to. They're not that into it, and they're kind of burnt out maybe. And I think part of that also is they're not willing to fail. Because in your failures, you're going to learn a lot about what happened and what didn't happen, and that's going to excel you. But people have an ego, and they don't want to fail. They don't want to look stupid in front of people, and that's what stops them from going to that next level.
Yep. All right, last question for today, David. If people want to find out more about you, get in touch, see what you're up to, where are they best to do that?
You can find us on Instagram, and you can find us on Facebook. We're Head Games Motorworks. You can also see headgamesmotorworks.com, or you can find me on YouTube. We've been trying to really push our YouTube recently with a lot of videos about how-tos, how to port, and a lot of the conversations that we had here today.
Perfect. All right, we'll put links to those as usual in our show notes to make it nice and easy for everyone listening to go and find those resources. Look, great chat today, David. I've certainly learned a lot, and we appreciate your time coming on the podcast. Thanks for coming on and chatting to us.
Man, I had a great time. It went way faster than I thought it would. It was actually so much more I wanted to talk about, but man, I really like what you're doing. You've been in my ear for the last couple of months as I'm sitting here grinding, and I put your podcast on Spotify, and I just really, really enjoyed it. You have a way. I'm a bad interview person. Like there's probably people who are listening to this just want to shut it off because I don't talk very well on an interview, but you seem to pull out the information. You're very humble. You say you don't know something, but it seems like you really are able. You're very versed and can pull some information out of people. So it's really cool.
I appreciate the kind words. I do my best, and the feedback we get seems like most people think that it's a worthy way of spending an hour and a half or so listening to this podcast. And yeah, it's just great to see the podcast grow, and we continue to attract great guests like yourselves. And basically, the more great guests we can get, the more information we can share with all our listeners. So again, thank you.
Thank you.
If you enjoyed this episode of Tuned In with David, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Mad Max from Canada, who has said, great talks with knowledge and experienced people from the tuning industry. Andre has a great way to popularize tuning terms, and everyone who listens to these podcasts can have a good time and take advantage of the info he gives. Well, thanks for the kind words there, and we really appreciate your review. If you get in touch with your t-shirt size and shipping details, we'll fire a fresh tee off straight out to you. All right, that concludes our interview, and before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.